Hi, welcome to another tech series video from SY Electronics, and today we're going to talk about working with high level line amp speaker systems. So high level or 100 volt line systems, or to give a more correct, accurate description, constant voltage speaker systems. They're a special kind of audio speaker system that can be used in instances where a greater number of speakers need to be used in a fixed installation of some kind, perhaps in a lecture theatre, or imagine across a large office premises where many speakers are distributed all over different areas of the building, a hotel or bar perhaps. Each speaker doesn't always need to be very loud, although they can be loud if they want to, but they need to be located or spread out across a greater distance. That's the key thing here. So this type of system can not only power many speakers over long distances, but also allow the volume level of each area or zone, or even each speaker, can be managed individually. So this type of speaker system may be referred to as a high level line speaker system or constant voltage line, but it's more commonly known here in the UK simply as a 100 volt line system. In the USA they tend to use 70 volt systems, and actually they are 70.7 volts to be precise. So the same principle applies whatever kind of system you use in this type of scenario. But anyway, it works in the same fashion. It works by stepping up the voltage level of the amplifier output signal, and it does this by incorporating a transformer within the amplifier after the output stage, and thereby stepping up the voltage of the audio signal that is presented at the amplifier's outputs to the speakers. Now, the maximum power possible from an amplifier will always be the same regardless of the voltage or current draw. An amplifier can produce a certain amount of power according to its design and specs. But therefore, as a result of this, as the voltage has been increased, the current of the said circuit will thereby be reduced. Another advantage of this system is that a much thinner speaker cable may be used to run out to all the different speakers and over a long distance. So as we can see, power, as we know, equals volts times current. And if we increase the voltage, then we have also decreased the current. The opposite is likewise true, but it suits us to send out signals at a high voltage but with a lower current, as we can then reduce the speaker cable size dramatically. This is obviously good for an installed system. So here is a simple explanation of how our constant voltage speaker systems work. The amplifier outputs the audio signal at 100 volts and feeds to the speakers through a twin cable. Each speaker has its own transformer attached to it that reduces that 100 volts peak signal back down to a lower regular voltage that the speaker can handle. Now, the transformer also may have many different tap points taken off the transformer that will let you choose how much power and the volume that each speaker will receive, so you can tailor it nicely. The speakers are connected in parallel, which means that they share the same cable and signal, and it's wired in a daisy chain type topology. But they do not affect each other's impedance or load, as each individual speaker has its own transformer mounted to it. So let's talk about measurements. When trying to work out the size of the amplifier that is required, or trying to establish the max speaker load that you can safely use on your high-level speaker line system, we'll first need to know or ascertain certain values or parameters. When you want to be able to find the minimum impedance value that's possible on your given 100 volt line speaker load, the formula is Z equals V squared divided by P. That's impedance equals voltage squared divided by power. For example, if you have a 100 volt line system and a 40 watt amplifier, then you will need to measure the total load of your high level speaker system. In this example, the minimum impedance equals 250 ohms. How do we get to this? Well, the formula we use, Z equals V squared over P, that will give you the answer of the impedance in ohms. So plug into this formula the things that we know. We're using a 100 volt line amp and we want to use a 40 watt power amp. So what is the minimum impedance value speaker load that we can use? Here's the maths. 100 volts squared equals 10,000. Therefore, 10,000 divided by 40 watts equals 250 ohms. The impedance can be more than this figure, as this would mean a lower wattage load on the amplifier, but not less than this, as that would result in overloading the amplifier's capability. It is recommended to only utilise up to 90% of the max rated power output of your amplifier. Therefore, if you had a 40 watt amplifier, we would try to provide a load of no more than 36 watts, as 90% of 40 watts equals 36 watts. Therefore, in this example, we will want to aim for a minimum impedance value of 277 ohms, as, looking at the formula, 10,000 divided by 36 watts equals 277 ohms. So to convert from the impedance readings on your meter, a standard impedance speaker reading meter, a bit like this one, we can use the formula to convert impedance to watts RMS, using the formula voltage squared divided by impedance equals power. For example, if you had a measured impedance of 666 ohms across your speaker line load, and you need to work out the load this would put on the amplifier in watts, then you can use the formula this way. So assuming again a 100 volt line system, we use 100 squared equals 10,000. So then we have 10,000 divided by the 666 ohms equals 15 watts RMS. So the load that this speaker line would draw from your amplifier, in this case, would be 15 watts. If all this is working out fine for you, then you could use a meter that reads out the speaker load in ohms, like the one that we just showed you. But if not, then you can use a different kind of meter that reads out directly in watts. It does the conversion for you. Something like the ELM1 is a good one for that. So I hope you found this informative and useful, and when you're using SY Electronics audio amplifiers that provide the 100 volt line output, you'll know how to do the calculations and what speaker load will match to the amplifier that you are using. So thanks for watching this video, and we'll see you on the next one.